down. School dismiss.
I am a teacher at a junior mixed school in Blackpool, and this is my class, consisting of 39 9 and 10-year-olds. At the beginning of a maths lesson, the first thing I've trained the children to do is to get a card from this rack on the wall.
The assignment card, as it's sometimes called, simply presents a child with a problem. A real problem. Not just a sum wrapped round with words, which we've often taken to be a problem in the past.
By pouring the water into the measuring jug. Shape and area. You will need a shape board and some rubber bands. Now fill each box with sand using a cubic inch. And
a problem has reality and it has interest for the child. It belongs to his world. And because it belongs to his world, he'll be interested in finding the solution.
Now then, we've to find how many peas there are in this jar. How many do you think there are, Jeffrey?
About 600.
About 500.
We have to measure the circumference of each ball. What is the circumference? The distance all around the ball. Well, we can't use a ruler for that. We'll have to use a string.
I think this is a preferable method of teaching mathematics, because it does demand that you, the teacher, get around the class and talk to these children and discuss with them their problems, and you can help them without telling them the answer or without giving too much away. You can, I think, gain the child's interest and help it very much more than you can simply by paper and pencil.
Yes, you could weigh the empty bottle on the scales and then weigh it when it's full of water and then double it and take it away, and then you've got the weight of a quart of water.
But that won't be right, you see, because not all the peas weigh the same weight. So
but if you consider really what research can tell us about how children think, how children learn, we must accept that they learn at this level purely through concrete situations, through things which they can do and handle and touch, and not through a world of abstract symbolism and things devoid of reality.
By 16, that makes 40 miles.
Do you think we should check it with the AA book?
Yes, the whole basis of what we are trying to do here is that by what we now call the concrete approach, if the child actually does something, handles something, he is more likely to retain it because it is an actual experience than he is by using his memory alone, or just by virtue of having been taught. We say that teaching by telling is often harmful, and that memory alone is useless. When you actually do something, it sort of sticks. Of course, everybody knows that for a certain type of problem you want a right answer. But the point is that you've got to be able to go on getting the right answer. If you simply do it by rote, by parrot learning, you're unlikely to remember it in a fortnight's time. But if you've really grasped the underlying principle, you'll not only be able to do the same problem, but also something a little bit different in a fortnight's time.
I think we must be aware always that memory, although a useful tool, is not the whole story. It's best put perhaps in the terms of a Chinese proverb. I hear and I forget. I see and I remember. I do and I understand. And it's this understanding that we're after, and that we can best make it possible for children to gain real understanding of the problem by allowing them to do, to be actively involved in something.
Good. Yes, you've balanced it. And that's called balancing the equation.
Well, if we double the dimensions, the cube gets 8 times bigger. Yes. Cubes get very big quickly. Should we make a graph to show it? Multiply the 3 dimensions of each box and write down your answer. We've done that. What do you notice?
Well, what do you notice?
You don't have to fill each box with sand. All you have to do is multiply the dimensions.
That's right. Good.
Please, sir, we found out that one of these blocks weighs 10 1/4 ounces. But we want to find out how many of them weighs 1 stone.
Please, sir, not all of these blocks weigh 10 1/4 ounces. This one weighs 9 3/4 ounces, and this one weighs 10 ounces.
Now, in this sort of problem, we're not really bothered about 1/4 of an ounce one way or the other. But we've got to settle for something. Now, what are we going to settle for?
10 ounces.
Yes, and I think 10 ounces is sufficient, isn't it?
Yes.
And I think if you use 10 ounces, you will be able to find that out very easily, and it's much better than messing about with all these quarter ounces.
What are the diameters?
Well, they could stick a pin through it if it wouldn't burn. Well, it will, so we'll have to use the calipers.
What other route do you know that would take you from Blackpool to Bowness?
Well, what other route is there to Bowness?
We can cut through Lancaster
Yes,
on
well,
the
that's by the
A6.
A6.
Or go on the M6.
We've got the Globe card this time.
I wish we had the train card. Can't we swap it?
No, Patsy Black's group's got that. Now then, we've to measure from London to Winnipeg and Blackpool to Auckland. Now then, we'll measure from Blackpool to Auckland first. To hold that on Blackpool, please.
It's on now.
Right. That's on Auckland. Right. Have you got your finger right on Blackpool?
So, if I gave you a diameter, you could find me the circumference, could you?
Yes.
What would you do, Jane?
Well, you multiply by 3 and...
A little bit. That would be all right, would it? Yes, it certainly would. Good. All right. Now, supposing I gave you a circumference.
In the past, we've tended to think, haven't we, that if a classroom was quiet, then there was concentration. And this isn't true at all. Concentration only comes through interest, through real involvement in what you're doing. If the children are presented with situations, with problems which are of real interest to them, they get so deeply involved in them that there's no unnecessary noise.
They're working something out. They're talking to each other, the same as adults talk over the problem. This is what we want, surely. We don't want children sitting up straight in their desks completely on their own.
Language plays an essential part in mathematics. Children must discuss with each other what they're doing, for by this means they learn. And in this way, children's vocabulary grows and, in turn, helps their written expression, their written description of the kind of things they've been doing. They learn more, in fact, from each other and from the material and the problems presented than they could ever do, sitting quietly listening to a teacher.
The important thing about this is that children are like us all. They do like this little bit of personal and individual attention.
Leslie?
But they much prefer that the teacher should come and talk to the three of them and stand out in front of the class like a sergeant major with a piece of chalk in his hand and talk to the whole class. Because I don't think that they feel then that it is personal to them. The more personal a teacher can get with his teaching, the more it is appreciated by the child. And the more response you will get from the child, too, if he thinks that you are talking to it personally.
But if they're involved in group activities, then it is possible to get round, to see them and talk to them, encourage them and perhaps pose an additional question which will help their thinking onto the next stage.
Now, have a look at these three plasticine shapes. All right? Derek, which do you think is the biggest of the three?
The cylinder.
The cylinder, all right? Now, Alec, which do you think is the heaviest of the three?
The cube.
Now, Chris,
The cube.
the cube. And which do you think is the heaviest?
The cube.
The cube again? All right. Well, we'll see, shall we? Thank you. Now, what's that?
2.5.
What's that?
2.5.
Chris, what's that?
2.5.
All right. Surprised? Now, something changes here, Edwina, when I move this new shape. Now, watch it carefully. Now, what changes?
The area.
The area, right. Now, Yvonne, something else is changing. What is it?
That.
That. What's that, Suzanne?
The height.
The height. Which height? The slant height or the vertical height?
The vertical
The
height.
vertical height. That's right. So, if I want to find the area of this new shape, which is a parallelogram, what must I multiply together? Yvonne?
The base by the vertical height.
The base by the vertical height. Now,
This
that's
is the
very-
basic difference, isn't it? Before, we were concerned with getting the answer right. And now the thinking teacher is concerned with how much of this did the child understand. How far has he got in his thinking? It's a complete approach from the old approach of accuracy and getting the answer right and getting it ticked.
After a while, I'm sure all children find this method much preferable. They enjoy their maths. They look forward to it. Because after all, it is something which they can enjoy. They're doing something. In some cases, I'm quite certain the children think they are having quite a game, but a very purposeful game, and from our point of view, we must see that this is so. I suppose the reason that the whole of maths teaching is in such a mess at present is that the syllabus hasn't changed, in effect, for 300 years. In fact, some Rip Van Winkle, coming back after being asleep for 1,000 years, would be able to do most of the O-level syllabus. In particular, the primary school syllabus was last fundamentally looked at over a century ago, when the main object was to train people to do sums on a high stool at a large desk, to be Victorian clerks. And until about 5 years ago, no one had ever thought of altering this dismal state of affairs.
What we're looking for is an improvement in the whole approach and attitude to the learning of mathematics. This we cannot yet assess, but we can say that there is interest, that children are now doing things at 9 and 10 which were formerly done at 13 and 14. I think we can widely generalize and say that we have underestimated children's ability in a very wide way. We haven't realized how much they're capable of. This we can be sure of. Anything else is prediction, which the majority of children have never had before.
Time! Pack up! Come on, bring the apparatus in. Playtime.